Summer is a lazy time for me. I'm lagging behind in my upload schedule big time. Doing nothing is great, but it's time to get off my butt and start working on a new video. In this one, I will give you a few tips when it comes to prototyping on a breadboard to make final design easier and more transparent. Some of those tips I picked up from other people, but some I came up with myself. Let's have a look at them. My second tip involves lily pad LEDs. Those LEDs are meant to be used to put Arduino LED designs on your clothing. You connect them with metal threads. They are nothing more than a small PCB with built-in LED and a resistor. I will now take two male header pins and try to solder this lily pad LED onto them. Done. Let's have a look at this. Ouch, ouch, too hot. So now we have the LED module with built-in resistor that we can plug in on the breadboard. So here's how we would connect a standard LED on a breadboard. I will use the power supply we discussed in tip 1, and then we connect LED anode through current limiting resistor to positive side of the power supply and LED cathode to power supply minus. And surprise, surprise, LED lights. Now let's do the same with our lily pad module. Again, LED anode and cathode are connected to power supply in the same way, but we no longer need the resistor as we already have a built-in one in the lily pad module. May seem not much of the improvement with one LED, but if you are connecting multiple ones, then believe me, it makes a lot of difference. On to next tip. This one will help us tidy up multiple connections, like shown here, by replacing jumper wires with custom-made connection wires. We will do it using scrap network cables. You have various types of network cables. You have category 6, then category 6A, and then category 7. I'll use the later ones. They are used for structural cabling of the office buildings. Inside there are 8 wires that are thick enough for our purpose. Let's take a piece of that cable and take it apart. I will get rid of the insulation first. Then I will remove steel wire shield. And then aluminum foil shield that protects individual cable pairs. We are ending up with 8 cables, 4 white, 1 blue, 1 green, 1 brown and 1 orange. Let's take a box cutter and create a connection wire by removing insulation at both ends of the wire and bending those ends so they can be plugged on a breadboard. Great! My next tip is to carefully choose the type of breadboard you are planning to use. A while back I created a project in which I was displaying animation on a small SPI OLED display. I used my custom-made wires then, as when using standard jumper wires they were obstructing the view of the OLED display. It worked, but was it optimal? Not really. The distance from Arduino pins to OLED display pins was too big. This can be fixed by using small breadboards, like this one. They do not have ground and VCC buses. You can mount them with a double-sided tape, but you can use it just once. So I would rather use 3D printed mount for those breadboards, especially when I plan to use multiple ones. So let's redo OLED animation project using 2 small breadboards. Here I use short jumper wires, as in this setup they do not obstruct the view of the OLED display. Now all I need is to connect Arduino to the PC and load the code. It works and it looks more slick than my previous setup, doesn't it?